P12-13. This is a revision video covering energy levels in atoms, which you did in those 2 lessons. So if the electrons in an atom get some energy, they can, under some circumstances, escape, and that causes ionisation. In other words, the neutral atom turns into a charged ion, and that's because you're adding or removing an electron from an atom. And adding energy generally allows an electron to escape. But if the energy isn't enough to actually ionise the atom, it could still excite it. And that means that the electron jumps from one energy level to another, but stays inside the atom. So that tends to be an unstable state for the atom, with its electrons up a level, or up more than one level. So after a very short time, the electron tends to fall back down, and the energy that was absorbed by the atom comes out again, and that energy is emitted as a photon. And when that happens, that's called de-excitation, so just the opposite to it. So energy in, electron jumps up a level, energy out, and the electron is falling back down again. So energy in can come from heating. So if you heat something up, it can start glowing. For example, when you put something in a Bunsen flame, or when you heat it on in a forge or something like that. So that can supply energy. An electron could come in and hit the atom and give some of its energy to one of the electrons in the atom itself, or a photon could come in and give an electron some energy as well. Energy out tends to be a photon. It may not be visible, so it may be in the invisible part of the spectrum, but it will still cause a photon to be emitted. So this is represented by an energy level diagram. So in this diagram, we've got 4 energy levels, 1, 2, 3, and 4. 1 is called the ground state, and that's where the electrons are most stable, so where they tend to fall to if they have jumped up. But they don't have to fall all the way down in one jump, so these ones are falling all the way down to the ground level. And because E equals HF, the further they fall, the higher the frequency. So we've got a blue photon, high frequency, a green one, medium, and a low frequency, so the red one. But they could fall down in more than one jump as well. And to calculate what frequency a photon comes out, you just need to use this equation. HF, the energy of the photon, is equal to the difference between the 2 energy levels. So you just have to read the numbers off of the energy level lines here. Don't worry too much about sign. I would suggest you just take the smaller number away from the bigger number, and you just need to be aware of whether it's the arrows are pointing down, in which case the photon's coming out, or if they're pointing up, that means the energy's going in. So here's some spectra. If you see a black line with coloured lines superimposed like these are called emission spectra. That's where, for example, you put something in a flame test and you look at it through a diffraction grating and you see individual lines, and that's because the photons are coming out of the atoms. So they've been excited in some way, they're dropping back down and emitting that little packet of energy as specific photons. So that's what you see when you look at them. An absorption spectra is like the negative of that. It's a whole spectrum, but with black lines, with bits missing. So that's when white light is shone through something like a gas. And because the white light has got all the different wavelengths of light in it, the wavelengths that correspond to particular energy jumps can get absorbed by the gas. So that wavelength is effectively plucked out of the spectrum, and you wouldn't see it. So these two pictures are the same element, but this is the emission spectrum for it, and this is the absorption spectrum for it. This is actually used when we look at starlight to work out what elements are in the star. One more thing you need to know about is fluorescence. So sometimes the element can emit some photons that we can't see. So for example, if it emits an ultraviolet photon, that's quite a high energy photon. But in a fluorescent light, for example, that's wasted because it's energy coming out, but the whole purpose of a light is so we can see by it. And if we can't see it, it's not very much use. So you put a fluorescent coating on the light, and that absorbs the ultraviolet photon, and then that electron drops down, rather than in one jump, in more than one jump. And because each jump corresponds to lower energy, that puts it back into the visible part of the spectrum, so we get more light out that we can actually see. So UV photon in, and 2 visible photons, or more, maybe 3, come out.